When dealing with 230 volts 3-phase ungrounded delta systems, ensuring electrical safety is crucial, and a ground fault detector with alarm functionality becomes essential. These devices constantly monitor the system for any unintended connection between a phase conductor and ground. If a ground fault is detected, the alarm alerts personnel to a potentially hazardous condition, allowing for prompt corrective action. Several commercial options are available to achieve this. Firstly, the Acromeg HP-500 series is a viable option. The HP-500 is designed to monitor ungrounded power systems and provide an alarm upon detection of a ground fault. Secondly, ASC Automation offers the T3P-7511-5-1 resettable ground fault detector. This device is specifically engineered for ungrounded systems, providing reliable ground fault detection and annunciation. Thirdly, Automation Direct offers the GFF-200. This ground fault detector is another option for ungrounded systems, providing visual indication of ground faults. Fourthly, consider the Beckhoff EL2801. This is an Ether CAT terminal that can be used for ground fault detection, especially within a Beckhoff control system. Fifthly, Control Dynamics manufactures the 7200-501 ground fault detector. This device is designed for industrial applications and provides reliable ground fault detection and alarm capabilities. Sixthly, the GLV7100 ground fault relay can be implemented. This is a sophisticated ground fault relay that offers advanced protection features for electrical systems. Seventhly, Phoenix Contact offers the GND5130 ground fault detector. This device provides reliable ground fault detection and is suitable for various industrial applications. Eighthly, the Siemens 7K MPAC 3200 Twintizer Azera power monitoring device can be configured to monitor ground fault current. This device is part of the Siemens power monitoring system and provides comprehensive power quality and protection features. Ninthly, Wago offers the 750-414 ground fault detector. This module is designed for use with Wago's input-output system and provides ground fault detection capabilities. When selecting a ground fault detector, several considerations are important. Firstly, ensure that the device is rated for the voltage and current of the electrical system. The voltage rating must be equal to or greater than the system voltage, which in this case is 230 volts. The current rating should be appropriate for the expected fault current levels. Secondly, consider the physical dimensions and mounting requirements of the device. Ensure that the device can be easily installed in the available space and that the mounting method is appropriate for the application. Thirdly, review the detection algorithm and alarm capabilities of the device to ensure that they meet the specific needs. The detection algorithm should be sensitive enough to detect even small ground faults, and the alarm should be clear and easily audible. Consider the response time of the alarm and whether it can be configured to latch or reset automatically. When installing and using a ground fault detector, it is important to consult with an electrician or qualified professional. They can ensure that the device is properly installed and configured and that it is integrated with the rest of the electrical system. They can also provide guidance on the proper use of the device and the appropriate response to alarms. The installation typically involves connecting the ground fault detector to the electrical system and configuring the alarm settings. The specific wiring and configuration will vary depending on the device and the electrical system. However, in general, the detector will be connected to each phase of the system and to ground. The alarm will be connected to a suitable annunciation device such as a horn or light. Regular testing of the ground fault detector is essential to ensure that it is functioning properly. The testing procedure will vary depending on the device, but it typically involves injecting a small test current into the ground circuit and verifying that the alarm activates. This test should be performed at regular intervals, such as monthly or quarterly. In addition to ground fault detectors, other safety measures can be implemented to protect against electrical hazards in ungrounded delta systems. These include the use of ground fault circuit interrupters, also known as GFCIs, on individual circuits, and the implementation of a comprehensive electrical safety program. GFCIs are designed to protect against electric shock by quickly interrupting the circuit when a ground fault is detected. They are typically used in residential and commercial applications, but they can also be used in industrial settings. A comprehensive electrical safety program should include regular inspections of electrical equipment, training for employees on electrical safety procedures, and the use of personal protective equipment. By implementing these measures, the risk of electrical hazards can be significantly reduced. Furthermore, understanding the principles of operation of an ungrounded delta system is crucial for ensuring safety. In an ungrounded system, there is no intentional connection between the system and ground. This means that a single ground fault will not cause a large fault current to flow. However, if a second ground fault occurs on a different phase, a short circuit will result. This can lead to equipment damage, fire, and electric shock. Therefore, it is important to detect and correct ground faults as quickly as possible in ungrounded delta systems. Another important consideration is the type of alarm that is used with the ground fault detector. The alarm should be clear and easily audible, even in noisy environments. It should also be located in a prominent location where it can be easily seen or heard by personnel. In some cases, it may be desirable to use a remote alarm that can be monitored from a central control room. In addition to the alarm, some ground fault detectors also provide a visual indication of the ground fault. This can be helpful for troubleshooting and identifying the source of the fault. The visual indication may be in the form of an LED or a display screen. When selecting a ground fault detector, it is also important to consider the environment in which it will be used. If the device will be exposed to harsh conditions, such as extreme temperatures, humidity, or corrosive substances, it should be rated for those conditions. Some ground fault detectors are specifically designed for use in hazardous locations. These devices are typically explosion-proof and are designed to prevent the ignition of flammable gases or vapors. Finally, it is important to keep accurate records of all ground fault events. This information can be used to identify trends and patterns that can help prevent future faults. The record should include the date and time of the event, the location of the fault, the cause of the fault, and the corrective actions taken. By following these guidelines, you can ensure that your 230 volts three-phase ungrounded delta system is properly protected against ground faults and that personnel are alerted to potentially hazardous conditions. Remember that electrical safety is paramount, and it is always best to consult with a qualified professional when dealing with electrical systems. Ground fault detectors are not a substitute for proper electrical safety practices. They are simply one tool that can be used to help protect against electrical hazards. A proactive approach to electrical safety, including regular inspections, training, and the use of personal protective equipment, is essential for preventing accidents and ensuring the safety of personnel. Furthermore, understanding the specific requirements of your local electrical codes and regulations is crucial. These codes and regulations are designed to protect the public from electrical hazards and must be followed. A qualified electrician can help ensure that your electrical system complies with all applicable codes and regulations. In conclusion, selecting and implementing a ground fault detection system for 230 volts three-phase ungrounded delta system requires careful consideration of various factors. From choosing the right detector model and brand to understanding the principles of operation and adhering to safety guidelines, a comprehensive approach is essential. By prioritizing safety and seeking professional guidance, you can effectively mitigate the risks associated with ground faults and ensure a safe working environment.